Okay, we'll be continuing with gas laws in this video, and then we'll be talking about Boyle's, and also we'll also talk about Charles, and then the general gas law, or what we call the general gas equation. So, what is Boyle's law all about? According to Boyle's law, the volume of a fixed mass of gas varies inversely with the pressure, provided that the temperature is kept constant. So that means at constant temperature, the higher the volume of a gas, the lower the pressure, and vice versa. And then the relationship is they are inversely related. So it's an inverse relationship. So mathematically, V, which stands for volume, is inversely proportional to 1 over P. This is how it is written. And then when we introduce the proportionality sign, it means that PV is equal to constant. So at any point in time, the pressure, the product of the pressure and volume will give a constant value at any point in time for a gas. Okay, so P1 times V1 is equal to P2 times V2. That's what Boyle's law is talking about. So the product of the volume and pressure, it's always constant. So mathematically, Boyle's law can be represented with an inverse graph as shown as, as shown in the screen. So when pressure is plotted on the vertical axis and volume on the horizontal axis, you get an inverse graph. So this is the graph that illustrates Boyle's law. And then, however, when pressure is plotted against the inverse of volume, that is 1 over volume, you get a straight line graph. It's still an inverse graph because of the variables that are on the axis. So let's see if we can answer some questions that are relating to Boyle's law. So the first question talks about a gas that occupies a volume of 200 degrees Celsius and then a pressure of 1.0 times 10 to the power 5 Newton per meter square. When the pressure is increased to 2 times 10 to the power 5 Newton per meter square, what will be the pressure? What will be the volume? So we have the first volume, first pressure, and then they are giving you the second pressure and telling you what will be the volume when the pressure is changed in that manner. So according to Boyle's law, P₁V₁ is equal to P₂V₂. Is that not so? So once we substitute, or even before we do, once we make V2 subject of the formula by dividing both sides by P2, we have that V2 is equal to P₁V₁ over P2, according to what we have here. So this is the formula we are going to be using. Why are we making V2 the subject of the formula? Because we're given the first volume and the first pressure. We're given the second pressure and we're looking for the second volume, which happens to be V2. So P1, as you can see in the question, is 1.0 times 10 to the power 5. It's well substituted. And then P2 is 200 cm cube all over 2 times 10 to the power 5, which is P2. So once you multiply and divide, you get that the second volume is 100 degrees Celsius. 100 cm cube. Take note, when pressure and volume are given and temperature is kept constant, the law to be applied is Boyle's law. Okay, let's move on to the second question. The second question says the ratio of the initial to the final pressure of a given mass of gas is 1 to ratio 1.5. Calculate the final volume if the initial volume was 300 cm cube. So of course, using Boyle's law, P₁V₁ is equal to P₂V₂, as shown. So the ratio of the final pressure, initial and final pressure, is 1 to ratio 1.5. So if we take the initial pressure to be 1, it means the final pressure will be 1.5. So once we substitute in that manner, 1, it will be 1 as P1, and then 300 as V1, and then 1.5 as P2, and then V2 is what we are looking for. So once you substitute, we divide, you substitute and divide, you get V2 as 200 cm cube. Okay, try doing this task. You can always discuss your answers or difficulties in the comment section. And then task 3 as well. It involves plotting a graph. So make sure you do these exercises. They help to strengthen your understanding or otherwise of the discussion so far. So any success or difficulty you have, just let me know in the comment section. Okay, so we'll be moving briefly to Charles' law. Charles' law talks about the relationship between the volume of a gas and the absolute temperature of the gas in Kelvin. So according to Charles' law, the volume of a fixed mass of gas is directly proportional to its absolute temperature, provided that pressure remains constant. At constant pressure, volume varies directly with temperature. So mathematically, this is how it is represented. V varies directly as T, where V represents volume and T represents temperature. So if we introduce the equality sign, we'll have a proportionality constant. That means V over T is equal to K, where K is the constant of proportionality. So if V over T is constant, it means that at any point in time, if we have a first volume V1 and a first temperature T1, a second volume V2, and a second temperature T2, it means that the ratio V1 over T1 will be equal to V2 over T2, would also be equal to V3 over T3. The ratio of the volume of a given mass of gas to its corresponding temperature in Kelvin, that's the absolute temperature, at constant pressure is always constant. That's Charles' law. So let's see if we can solve some examples. The volume of a fixed mass of gas measured at atmospheric pressure and 27 degrees Celsius is 3 dm cube. Calculate the volume at 127 degrees Celsius at the same pressure. So that means pressure was kept constant. As long as pressure is kept constant and temperature is changing, it means that any problem you are asked to solve would require the use of Charles' law. So first, the temperature was given to us in Kelvin, so we need to convert it to degrees Celsius. Remember, when the temperature is given to you in Kelvin, you add 27, is given to you in degrees Celsius rather, you add 273 to it to get the equivalent Kelvin temperature. So that means 27 degrees Celsius plus, or 27 plus 273 will give us 300 Kelvin. So as the initial temperature T1, and then T2 from the question that we were given is 127 degrees Celsius. So we add 273 to it to convert it to Kelvin. It gives us 400. So remember Charles' law, V1 over T1 is equal to V2 over T2. So when we apply the law, and then we make V2 subject of the formula, because that's what we are looking for. So calculate the volume. So we would have that V1 times T1 over T1 would give us V2. So when we substitute, V1 is the first volume. It was given to us as 3 dm cube, and then T2 is the second temperature. It was given as 400 Kelvin, and then T1 is the first temperature. It was given to us as 300 Kelvin. So once you substitute and divide, multiply and divide, you get that V2 is 4 dm cube. Take note. Okay, example 2. A given mass of gas occupies 500 cm cube at 25 degrees Celsius. Calculate the temperature in degrees Celsius at which its volume becomes doubled at constant pressure. So pressure is kept constant. They are telling you to calculate temperature. It means we'll be using Charles' law here as well. So V1 is 500, is the first volume. T1 is 25 degrees Celsius. But remember, we need to put these temperatures in Kelvin. So it will be 25 plus 273. And then we'll give you 298 Kelvin. V2 is the second volume. They say the volume becomes doubled. So that means if it was 500 cm cube before and is doubled, it means it will become 1000 cm cube. And of course, T2 is what we are looking for. It's unknown. So once we apply Charles' law, we would have that T2 is V2 times T1 over V1. So we just make T2 subject of the formula. So once we substitute the respective values that we've written down, we will get that we'll obtain 596 Kelvin. But remember, the question says calculate the temperature in degrees Celsius. So you need to convert 596 Kelvin back to degrees Celsius. And as you can see on the screen, it has been done, and it's 323 degrees Celsius. It's just a matter of subtracting 273 from 596 Kelvin. Okay, example 3. Is a gas sample with an initial volume of 3.25 dm cube is heated and allowed to expand to 9.75 dm cube at constant pressure. What is the ratio of the final absolute temperature to the initial absolute temperature? So this a little bit trickish, but very simple. So don't forget Charles' law. So final temperature to initial temperature. What's the ratio of the final temperature to the initial temperature? Final temperature is T2. Initial temperature is T1. So we need to rearrange the formula so that we can get T2 over T1. So and that was what was done in here. So T2 over T1 is V2 over V1. So once you substitute, you get the ratio that is asked. The ratio is actually 3:1 when you substitute in the equation appropriately. Okay, from what I've done so far, from what we've done so far, you can attempt task 4. This will give you mastery, and they will test your understanding. Pause the video and do these tasks, and then discuss your success or otherwise in the comment section. Okay, I hope you've done that, and I hope it went well. We'll be talking about general gas equation. General gas equation basically combines Boyle's law and Charles' law. For example, Charles' law, Boyle's law states that volume is inversely proportional to pressure, and then Charles' law states that volume is directly proportional to temperature. So, using the concept of joint variation, we can combine this these concepts together and see what we will get. So it means that volume is directly proportional to temperature and inversely proportional to pressure, as you can see on your screen. So this is what we have here. So this is the joint variation, basically just combining both of them together. And then once we introduce a constant, we would have this volume is equal to k T over P. Once we rearrange, we have PV over T is equal to K. This is a general gas equation. So it means that the product of the pressure and volume of a gas divided by the temperature would give us a constant. It also means that P₁V₁ over T1 is equal to P₂V₂ over T2 is equal to P₃V₃ over T3, and so on and so forth. So as long as you multiply and divide correctly, you get a constant value. So this is the general gas equation. Okay, let's see, using the general gas equation, how much of these tasks that you can attempt. Try attempting them on your own, and then I think in the next slide there will be answers. So pause the video, attempt the task, and then cross-check before you go on to doing an independent task. So I will give you a few seconds to do this task and then check the answers. Okay, I suppose you have paused the video and then you have done the task. So this, okay, let me go back. So the first question says, show that for a given mass of gas, PV over T is equal to constant. Define all variables in the expression. This is basically what we did in the previous section. So you can refer to it to get better understanding. There's no point watching the video if you don't have a firm grasp of this concept. Okay, so 170 centimeter cube of hydrogen gas is collected at 26 degrees Celsius and 736 millimeter mercury. Calculate the volume at 0 degrees Celsius. And then standard pressure is 760 millimeter mercury. So that means the pressure of the gas at 0 degrees Celsius is 760 millimeter mercury. So this is question 2. And then if you solved it correctly, this is the steps that you're supposed to do. State the general gas equation. Why? Because you have volume, you have temperature, and you have pressure, and none of them is constant. They are changing. So calculate the volume at 0 degrees Celsius, and then that means the volume will be different at 0 degrees Celsius, and then at standard temperature of 760 millimeter mercury. So the first volume is V1 is 170 cm cube. The first temperature is T1, is in degrees Celsius, so we had to convert to Kelvin. That's 26 plus 273, and then it gave us 299 Kelvin. And then the first pressure is 736 millimeter mercury, as P1. Okay, so let's go on to the second things that we're giving. We're trying to calculate the second volume, that's V2. So from the general gas equation, once you make V2 subject of the formula, you will get that V2 is equal to P1 V1 T2 over T1 P2. So from the general gas equation. So once you substitute everything that we've written here, you have that V2 is 149.38 cm cube. So take note. So approximately that's the V2. And then in question 3, that's what we're supposed to get. I hope you got it. To what temperature must a gas at 273 Kelvin be heated in order to double its volume and pressure? So this is a multiple choice question. So to what temperature that means they're asking you for a final temperature. An initial temperature was provided. In order to double its volume, that means the volume will change from V1 to V2. And also double the pressure. So basically, since volume, pressure, and temperature are changing, it means that the right equation, the right formula to be applied is the general gas equation. So and that's what we have here. So we write what we were given. First temperature is 273 Kelvin. First pressure wasn't given, but let the value of or let its value be P. And then first volume wasn't given, let the value be V. And then second temperature is what we are looking for, is unknown. And then we're told that P2 is 2P1 because they say the pressure is doubled, or 2P as the case may be. And then V2 is 2V1, which is also 2V. And then once we substitute, we'll have that PV over 273. Remember, P1 in the general gas equation now. In the general gas equation, P1 is P and V1 is V. So once we substitute, and then T1 is 273. So once we substitute, we'll get PV over 273 is equal to remember that P2 is 2P1, and then which is 2P, and then V2 is 2V1, which is 2V. So once we substitute, you get 4PV altogether over T2. So once we cancel out PV, because PV is common in both sides, we'll have 1 over 273. 1 over 273 is equal to 4 over T2. So at the end of the day, it means that T2 is equal to 4 times 273, which is 1092 Kelvin. So take note, you can replay this section over and over again if it looks too technical, but I feel it's quite easy to understand, and I hope you got it anyway. Okay, 4 says a given mass of gas occupies 500 cm cube at 30 degrees Celsius and 6.5 times 10 to the power 3 Newton per meter square. Calculate the volume of the gas at 50 degrees Celsius. So let's see, we're given first volume, right, which is 500 cm cube, and then first temperature 30 degrees Celsius, and first pressure. Calculate the volume of the gas at 50, that's the temperature is changing, and standard pressure, it means the pressure is changing, and then that means the volume will change as well. So it means that we are using general gas equation. So as usual, P₁V₁ is equal to P₁V₁ over T1 is equal to P₂V₂ over T2. And then what is V1? The first volume is 500. T1 is 30 degrees Celsius. We need to convert it to Kelvin. That's by adding 273 to it. When you do, you get 303 Kelvin. And then the first pressure, P1, is 6.5 times 10 to the power 4 Newton per meter square. So V2 is what we are looking for. Is to calculate the volume of the gas. So but we know T2 to be 50 degrees Celsius. When we convert to Kelvin, we get 323 Kelvin. And then P2 has already been given in the question to be 1.01 times 10 to the power 5 Newton per meter square. So we'll just substitute into the formula and solve. So once we do, we'll get that the final volume is 343.4 cm cube approximately. So follow the solution. You can substitute on your own and then solve with your calculator to see if we arrive at the same answer. If we don't, let me know in the comment section. Okay, Question 5 says explain why an increase in the temperature of a gas of fixed volume results in an increase in pressure. So why does temperature of a gas increase in temperature leads to increase in pressure? First, kinetic energy and temperature. I did mention while we were stating the kinetic theory of gases that that the higher the kinetic energy of gas molecules, the higher the temperature, and then the higher the temperature, the higher the kinetic energy. So when gas molecules move with higher energy, they will exert higher pressure. So that is why increase in temperature leads to increase in pressure. Another reason is collisions. When molecules are moving at high speeds, it means they collide more often. They collide more frequently with themselves and the walls of the container, thereby exerting more pressure. That's another reason why increased temperature leads to increased pressure. Another reason is the pressure exerted. So when the frequency of collision is high, it means that the force exerted per unit area is equally high. So of course, force per unit area is pressure. So that's one reason why high temperature leads to high pressure of gases. And then another reason why increased temperature leads to increased pressure is that the volume of the gas is fixed. The container doesn't increase in size. So that means the gas are moving more violently, and then they are colliding more with the container. But if the container were to increase in size, the gases will have to travel further distance to collide with the container, and then it will not affect the pressure as such. So fixed volume, when temperature increases, leads to increased pressure. Okay, this is the next exercise. Endeavor to do it. This is an independent exercise. I will only know about your progress in the comment section. So pause the video and then try to get this done. I want to know about your success or otherwise in the comment section. So in the next video, we'll be talking about Dalton's law of partial pressure and other laws. So please stay tuned and take